Okay, hi guys. I hope you're having a good weekend. It's Mr. Rocco, and this week it's going to be 3 videos and some worksheets to do that go with the videos. Again, please watch these videos. I understand some of you put it in 2x speed. As long as you can understand the material, that's fine. But you need to watch these videos in their entirety and refer back to them when you're working on the worksheets, because the answers, a lot of the answers, not all, but a lot of the answers come from these videos that will help you with the worksheets. Okay, so this week it's about latitude and longitude. That's part of the week. So I'm going to make 2 videos here. I'm going to make a video on latitude right now, and then I'm going to make a second video number 2 on longitude. And we'll go from there. All right, so we're going to start with latitude. Oops, wow, that was a horrible line. Trying to draw straight. Anyway, moving on. Latitude and longitude is the Earth point locating grid system, and it uses 2 stars. Latitude uses Polaris, and we talked about that last week when we referred to evidence for the Earth's shape. And then the sun, or what they call solar time, is used when we do longitude. But right now we're going to stick with latitude. It's a grid system, lines that run horizontal, lines that run vertical. It was proposed many years ago, thousands of years ago. I talked about a guy named Eratosthenes last week. He proposed the first latitude longitude system, and it's used to find your location, basically, in degrees. So let's start with latitude. Latitude is your location north or south of the equator in degrees. Latitude runs from 0 to 90, only 0 to 90, as opposed to longitude, which we'll get to, which goes 0 to 180. But latitude covers north, south of the equator in degrees 0 to 90. For example, Rhinebeck is 42 degrees north latitude. So we are 42 degrees north of the equator. When they say, what's your latitude? Rhinebeck, 42 degrees north. You are 42 degrees to the north of the equator. So here's how Polaris will help you find your latitude. So you look at this picture here. Again, Polaris sits above the North Pole axis. So this guy up here at the North Pole can look straight up. So it says people here look straight up at a 90-degree angle to their horizon, and therefore if Polaris, the light from Polaris is at 90 degrees straight above this guy's head, they are standing at 90 degrees north. So whatever that angle of Polaris is exactly the same as their latitude. The 90 is right here. 0 is the horizon, which is the line of sight. So if you look at the sun rising in the morning or the sun setting in the evening, look straight ahead, and where the ground meets the sky, right? The ground meets the sky. That's 0. So right through this guy's head right here is 0. And then you're looking at the light coming directly down on top of the guy's head. This makes a right angle right in here. And so that's where that 90 is. So anybody standing at the North Pole is their latitude is 90 north, and that's because Polaris is at 90 degrees. Clear that. This guy over here in the middle, they call these the middle latitudes. The guy up at the North Pole is called the upper latitudes. So now this guy at the middle latitude, his horizon line, let me see if I use a straight tool here, is right here, going through his line of sight. And the light from Polaris, oops, let me get my straight tool again, it's coming down again, parallel lines like this, right to his line of sight. He's looking up into the sky, and this angle right in here would be 45 degrees. And so it says over here, anybody here sees Polaris 45 degrees to their horizon, and therefore they're standing at 45 degrees north. So again, this is a 45 degree angle, and that's why you're at 45 north. Whatever this is equal to that. And then the last one would be this guy at the equator, which is the furthest south you can see Polaris. So in this case, the light from Polaris is coming down here, it's also the horizon line, which is straight ahead. So if you were standing at the equator, you would look straight ahead of you where the land meets the sky, and that's where Polaris is. And it says that over here, people standing here see the North Star right at the horizon, 0 degrees, and therefore their latitude is 0 degrees. All right. The problem with Polaris, again, is it's a North Star. Well, not really a problem for us. It's a problem for the southern hemisphere. Is once you go below the horizon, or once you go, below the equator. Here's the equator. Once you go down here, because of the curvature of the Earth, you can't see that light. So this is the furthest south you're going to see Polaris. Anywhere in the southern hemisphere can't see around the curve of the Earth to see the light that's coming down from Polaris. And so that makes it tricky. They use that. It was called Sigma Octantis. That was the South Pole star. So our North Pole star is Polaris. Theirs is Sigma Octantis. Lines of latitude have another name. They're called parallels. Just like in math class, parallel lines, right, are lines that are the same distance apart. They never get closer to each other. They stay perfectly flat and equal distance apart. No matter where you are, you could be over here, you could be over here, you could be here. Anywhere around the globe, the distance between latitude lines is going to be the same. That's not going to be the case for when we get into longitude. And again, you probably covered this in earlier grades. Longitude lines go with the curvature of the Earth. So they all connect at the poles, and then they kind of curve like lines on a basketball and go from pole to pole. But they get closer together, and they also get further apart, longitude lines. But latitude lines stay, they're parallel, so that's why they call them parallels. So this just shows the same thing here. Again, the person at the equator looks straight ahead. This line would be the horizon line. Polaris is sitting right where the land meets the sky. So because they see Polaris at 0 degrees, they're standing at the equator. This person is at 45. This angle right in here would be a 45. So they're standing at 45 degrees north. And this person sees Polaris straight up over top of their head, makes a right angle, 90 degrees. So they're standing at 90 degrees north, or the North Pole. Again, to find Polaris, it's the Big Dipper will help you find Polaris. It's not in the Big Dipper, as I talked about in last week's video. It's in the Little Dipper. Polaris is the last star in the handle of the Little Dipper. But again, the Little Dipper is hard to find because these stars are much fuzzier, other than Polaris. Polaris is a very bright star. But the Big Dipper is easier to find. So you look north, and you could try this week on a clear night. Just go out, look north, find the Big Dipper, use the 2 stars that make up the right-hand edge of the cup. Those are called those pointer stars. They will point you in the direction, so you just make a line with your eyes and head in that direction a little bit. You don't have to go too far up above the Big Dipper, but just use the pointer stars and start to draw your eyes up, and you will see Polaris. A very, very bright star. And then if you can find Polaris, you can sort of make out the handle. There's 4 stars that make up the handle, and then the 4 stars that make up the cup of the Little Dipper. The dippers kind of face each other, like this one is pouring water into this cup. So they're kind of upside down. And these will continue to rotate. Again, this is right above the axis. Polaris, I showed you that video with the circumpolar. So what'll happen is everything's going to pivot around this point. Put an X. So that's your pivot point at X. Everything's going to rotate counterclockwise like this around that pivot point. Same thing here. So again, if you're standing at the equator, you'd be here on this island on the beach, and you're looking, Polaris is right on the horizon. That's 0 degrees. This person is in New Orleans, Louisiana, which would also be the same as Jacksonville, Florida. So northern Florida, New Orleans, Polaris is at a 30-degree angle, so you're standing at 30 degrees north. And then this person's at the North Pole, which makes that right angle right there. 90. This would be 90 degrees north. So again, whatever Polaris is your latitude. So this would be, what is this person's latitude? Be careful on these kind of questions. They're going to give you 2 numbers. Both of them will add up to 90. In math class, I'm trying to remember my math days, I think those were called complements. right? Supplements, I think, are 180. Complements add up to 90. So you notice 54 plus 36 will add up to 90. But in this case, you want to always pick from the horizon. When you measure a star, zero's down here, not the vertical line, the horizontal line. And so you start on the ground and work your way up. So the angle you're looking at is not the 54. You want the 36. So since Polaris is 36, and they said, what is this person's latitude? 36 degrees. You want to put the degree symbol, and you want to get the north in there. Very important to have the unit. That's the unit. So you can't just say 36. You got to get this degree north in there as well to get full credit. What would be this person's latitude? So the horizon line, again, is this line that goes right through her head. Right there. That's your 0. Again, when you measure a star, you go from the horizon up. So you're looking at Polaris here. This is the angle, 32 degrees, right? 58 is the complement, but I don't want that. I get rid of that one. I always go from the horizon up. So if the North Star or Polaris is at 32, she's standing at 32 degrees north. Latitude lines, again, are called parallel. The way I remember latitude, I rhyme lat, to take the first part of latitude, lat, with flat. So lines on a globe that are the flat lines are latitude. Flat rhymes with lat. I think I remember in elementary school, my teacher taught me latitude ladder. I didn't like that. It confused me because then I started thinking, what do you do on a ladder? Oh, you climb up and down on a ladder. So that's what confused me using ladder. You know, I think what my teacher was trying to say, oh, if you think of a ladder, you think of the rungs on a ladder, like the steps, and that's where the latitude. But I always got confused because I said, oh, latitude, ladder, you go up and down. So on a globe, the up and down lines must be latitude. But see, that confused me. I like lat, flat, because everyone knows what flat is, right? Flat lines going this way, horizontal. So lat rhymes with flat. So here's your latitude, right? Lat, flat. The tricky thing about latitude that always gets confusing is they measure the opposite way you draw them. So even though you draw latitude lines flat, you measure north or south. And I think that's why my teacher in elementary school was trying to use that. Ladder, oh, you measure up and down. But again, I think the drawing and the way they're read are different. So I like to just remember lat, flat, they're flat lines, but then you have to just realize, oh yeah, when you measure them, you're going up and down like a ladder, I guess, to a certain extent. These are just some special latitude lines or parallels. If you look at the north border of the United States, not New York, we're, when you go up to the Canadian border up here by Plattsburgh, New York, we're at 45 degrees. That's the furthest north. And then you cross the border in heading toward Montreal. But the 49th parallel, that's over in the western United States. That's the boundary between Canada and the U.S. When you go out to Montana and Idaho and the Dakotas, North Dakota, South Dakota, Minnesota, up there is the 49th parallel. So that separates Canada from western U.S. Then the Koreans, North Korean, South Korean, that's the 38th parallel, which separates that country. And Vietnam, right? We had the Korean War, and then we had the Vietnam War. That was in the 60s, 70s. That's the 17th parallel, which is 17 degrees north latitude. That divides North and South Vietnam. I think I have some pictures here. Yeah. So if you look at this picture down here on the right, you got China, Japan, the Koreans, South Korea, North Korean, I call them the Koreans, North and South, they are up here, farther north, up by Japan. So this line right here that separates Korea is the 38th parallel, which separates North from South Korea. So that's 38 north. Again, Rhinebeck is 42. So this boundary would be slightly lower than us, but not much, only a couple degrees latitude lower than Rhinebeck. And then way down here, as you get toward the Philippines, and here's Taiwan, and you've got Vietnam. We had the Vietnam War. That's much further south, a much warmer climate than Korea. I mean, Korea has winters, especially North Korea. But south and North Vietnam is separated by 17 degrees of parallel. 17 degrees would put you way down below even Florida, because Florida, let's see, Miami is about 25 degrees north, so you're talking this is 17 degrees north. You're even further down. That would be like putting you toward South America almost, or at least like the Caribbean islands is where the Vietnams would be. This is a typical question on the regents that you'll see. So they show the guy, he's looking with an instrument to find the angle of Polaris. So here's Polaris. And again, the horizon is where you start. That's 0. And then again, they give you two numbers that add up to 90. Those are your complements. But again, you always pick the number that starts from the horizon to the actual star. So the angle you're looking at is this one. You get rid of the complement. You don't want the top one up here. You want this one, the lower one. And so if this guy sees Polaris at 66.5, and then the question is, what is his latitude? 66.5 north. So whatever the angle Polaris is the same as your latitude. This was a question, actually it was just on, well, the last, I guess, regents that was given prior to COVID, which was the January 2020 was the last test given, because the June one was canceled, August was canceled. Anyway, they gave them a map, or a globe, with some locations, A, B, C, D, E. It said, from which location would a person never, and see, they stressed it in italics, never see Polaris. And again, like I mentioned earlier, you can only see Polaris from the equator north, right? Because the equator is 0 degrees, the North Pole is 90 degrees latitude, and then anything in between. Once you go down here, you cannot see Polaris. So it would have to be either D or E, and then you go to your choices, A, B, C, D. So you see they gave you D. Big mistake would be to give you D and E, because then you have two correct answers, but notice they didn't do that. They gave you A, B, C, and then D. So anywhere up here, yes, you can see Polaris from A, B, C. Another question they could throw you, I'm trying to think of another way they could do it. They might say, well, it'd be tricky on this one, but they let's say they took A, wasn't here, and they put A, up here more, and they might say, from which location would Polaris be the highest in the sky? So in that case, you would have picked A. Or they could have said, from which location, A, B, C, or D, is Polaris the lowest location? You would have picked C, because that's the closest to 0, right? Closest to the equator. So something like that they could have given you. But in this case, they asked on the last test in January, which location would you never see Polaris? Again, once you cross into the southern hemisphere, you can't. So D would be the correct answer here. You can't see it in the southern hemisphere. And one more thing. So Polaris, or degrees, I should say, latitude, can be broken down into smaller units. And I teach this every year I tell kids, think of a clock, right? If you have a clock, how many minutes are in an hour, right? And the answer is 60. And then if I said, okay, how many seconds are in a minute? 60. So if you remember that there's 60 minutes in an hour and 60 seconds in a minute, you're breaking down an hour, right, into smaller units. So an hour is broken into 60 minutes, and a minute's broken into 60 seconds. It works the same way with latitude and longitude. So, and they use the same words, minutes and seconds. The only thing you have to substitute is, instead of hours up here, just call it degrees. So it's to zoom in. So like if you've ever used programs like Google Earth, right? Google Earth, you go on a map and you can zoom and click, 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 click with the mouse, and you can zoom right in on like street level, or even find your house in Rhinebeck. When you do that, and Google Earth will do this for you if you play around with Google Earth, you will narrow down your latitude and longitude into very specific units called minutes and seconds, right? Because degrees is not big enough. A degree, actually 1 degree of latitude is equal to about almost 70 miles is equal to 1 degree of latitude. And so, right, your house isn't 70 miles big. So you got to get down into even smaller units. And so they use minutes and seconds. So I always teach this with students. I say, just think of a clock, substitute the word hours, and put the word degrees there. And then it's the same words. So 1 degree is equal to 60 minutes, just like an hour is equal to 60 minutes. And so to use the symbol for minutes in latitude and longitude, they use a slash, one little slash. So if you see 60 with a slash, that means 60 minutes. Or 1 minute, one slash means, right, minute equals 60 seconds. They use 2 slashes. So 60 seconds, 2. So it's 1 slash means minute, 2 slashes mean second. And I gave an example here. Let's say you're looking at a location, and this is longitude, not latitude, but it works the same. Let's say a location is halfway between 73 and 74 degrees west. So you could write it like this, right? Let's say, let me clear this. Let's say I've got 2 longitude lines. This is 73 degrees west, and this is 74 degrees west. And I've got an X right in the middle. You say, well, Mr. Rocco, that's halfway. It's 73 and a half. You could write it like this, 73.5 west. You could write it with a fraction, 73 and a half. Or if they say, please write it in minutes and seconds, this over here would be the correct way to write it. You'd say, okay, it's halfway. Think of a degree as an hour. What's half an hour? 30 minutes. So you would write it 73 degrees, 30 minutes with this 1 slash, 0 seconds, 2 slashes, west. So these, all 3 of these mean the same thing. 73 degrees, 30 minutes, 0 seconds is equal to 73.5 is equal to 73 and a half. So here I wrote it in minutes and seconds, decimal, fraction. Okay, all mean the same thing. Then think of a clock, right? If you say, well, how much of an hour is 15 minutes? Oh, that's a quarter. So if a location was, let's say this is, 40 degrees north, and up here was 41 degrees north, and X was right about here. And you say, well, that's about a quarter past 40. It's heading toward 41, so it's 40 and a quarter. So the way you would write that, you could write it 40.25, or if they said write it in minutes, you'd say, all right, what is a quarter of an hour? So you think of, wow, that's a horrible circle. Try to draw that again, Mr. Rocco. Okay, so you think of a quarter of an hour is 15 minutes. So you'd write it like this with a 15 slash. So you'd say 40 degrees and 15 minutes north, 1 slash. Or let's say again, halfway was 30, or if it's 3/4, think of 3/4 of an hour. Oh, that's 45 minutes. So you'd write 40 degrees and 45 minutes north. If it was, let's say the X was maybe up here more. All right, so you would use minutes and seconds when you're getting into very, very specific locations. And then I gave you a little equivalent down here. Every minute of latitude, and remember there's 60 minutes in a degree, is about a mile. About roughly a mile. Every minute of latitude every second of latitude is about 90 feet. So that's when you're zooming in on Google Earth and you're down to your house, right? You're click, 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 street level. You're into the seconds. You know, if you move the mouse from your house to your neighbor's house, it might move a couple of seconds of latitude. Okay, so very, very small fractions of increments. So again, just remember, an hour is 60 minutes, and minute is 60 seconds. You use the same terminology, minutes and seconds. 60 minutes in a degree, 60 seconds in a minute. In your reference table, and I would recommend you do this, take a pencil. I usually do this in class. So take a pencil, and if you have a ruler at home, hopefully, actually I did give you a ruler. So you should have a ruler in that science kit I gave you. Use that ruler, use a pencil, and go to page 3 in your reference table. And you're going to create the grid on New York State. So let me just show you what I did. And then I strongly recommend you do this. So on this map, this is on page 3, the map of New York in your reference table. I'll just kind of circle the numbers there, and you'll see them as you look at the map. Way over here, I'll start at the bottom. Tip of Long Island, you'll see a 41. And then somewhere over here by New York City, there's another 41. Take your pencil, there's little plus symbols, and just draw a line very lightly in pencil. Connect the 41s with a straight line. And then I made a bigger number so you can see it's right on that line, 41 degrees north. And then you're going to keep working your way up. Over here to the right of Kingston, you'll see a 42. Right along the edge, they put the latitude numbers. These are your latitudes, 42. And then they put another one on the opposite side of New York, way out here by Lake Erie. Again, take your pencil and just draw a straight line connecting those 42s and label that 42 north. And you're going to keep going. So here's a 43, and there's a 43 over here. Again, draw the 43-degree north line. And again, put a bigger number on your ESRT. And then 44 up here by Lake Champlain. And there's a 44, where is it? Oh, right here in Lake Ontario. Draw another line. And then up at the Canadian border, there's a 45 up here. And over here by Messina, a 45. So draw the horizontal lines and connect the 45s, the 44s, 43s, 42, 41s. Then what I would do is go back and do the longitude lines. So way down here off the coast of Long Island, if you start at the bottom, there's a 73. And if you go way up here in the right-hand corner, top right, there's a 73. So that's west. We are west of the prime meridian, which is over in England. So connect this 73 up here, draw a straight line with the ruler down to this 73. You'll see those little plus symbols. They give you pluses. So connect that plus to that plus. And again, label that 73 west. And then there's a 74. And just south of New York City, there's a 74. Connect those. There's 74. There's a 75 up here by Messina. And there's a 75 right here. Connect those. And just keep going. 76 and 76. 77's right here in the lake. And 77's down here by the word Pennsylvania. Connect those with a line. 78's Lake Ontario and over here. And 79. Connect the 79's. So I would create the grid. Like draw the horizontal lines for latitude and number them. 41, 42 north, 43, 44, 45. And then I would do the 73s. Or 70s, starting with, you could do 72. I did that as well. There's a 72 way out here on the tip of Long Island. There's only one, so I just made a straight line, as straight as I could up and down, and labeled that 72 west, right on the tip of Long Island. And then I did 73, 74, 75, 76, and these are west. So all of the latitudes are north, and all of the longitude lines are west. This way, you might say, why do you need that? That'll give you a nice grid. So some of the homeworks, I think this week, they're going to ask you to find a location, but it might say go down to the nearest minutes. So for example, let's say Ithaca. Ithaca, New York's right over here. I'm going to put an X. All right. If I said, what is the latitude and longitude of Ithaca, New York, but give it in minutes, degrees and minutes. So you could say, well, it's about halfway between 42 and 43. So if I was putting the coordinate for Ithaca, I'm going to call that 42 degrees and 30. Remember, half an hour. Think half a degree, half an hour is 30 minutes with a slash north. If I'm doing the longitude, you'd say, all right, that again is about halfway between, what's this line, 76, and this is 77. So I'm going to call that 76 degrees and 30 minutes west. So to really narrow down, because I want that spot right there, Ithaca, it's halfway between these two latitudes, and it's halfway between these two longitudes, I'm going to use those minutes. 42 degrees and 30 minutes north, 76 degrees, 30 minutes west. Seconds, I wouldn't worry about seconds, because remember, seconds is 90 feet is a second. You're not going to see seconds on this map. But at least do the minutes. Let me do one more, just an example. Let's pick another city. Let's do Buffalo. See Buffalo right up here? I'll put an X where Buffalo is. So this is 42, this is 43. You might say, well, it's not quite 43, Mr. Rocco. Nope. So now I think of a clock. See, I put a clock up here just to remind you. So that's almost to the top of the hour. You're almost to the next degree. Every degree is at the 12 o'clock. So if you say, well, it's just a little short of that, I might use this one right here. How many minutes is the 11, right, on the second hand, or the minute hand? That's 55. So I might call this 42 degrees, 55 minutes north. that means I'm almost to 43, right? The 55, think of the clock, top of the hour, almost made it. 42 degrees, 55 minutes north. Same thing for longitude. You say, well, this is 78 west. This is 79 west. I'm not quite 79, so I'm just shy, maybe 5 minutes approximately, before I hit 79. So my longitude's going to be 78 degrees and 55 minutes with a slash west, because I'm almost to 43 and I'm almost to 79. Okay. And that's how you approach that. So cities are not always going to be exactly on an intersection. Not going to be here. They're not going to be right, nice, even whole numbers. So that's why the minutes and the seconds, and I'll leave this clock will be on there in my notes. So use this clock as kind of example, right? A quarter of a degree is 15 minutes. Half a degree is 30 minutes. 3/4 is 45, but it could be anything in between. I mean, I could look at, I'm trying to think one other one over here. Let's see. I could look at Rochester. Rochester sits right about here. Okay, I wouldn't say halfway. This little plus symbol is halfway between 43 and 44. So if I said, hey, what's the latitude of Rochester? I say, well, it's not quite 43. It's a little above it. But I'm going to think of a clock. Is that a quarter? It might call it 10 minutes, right? It's a little bit above, or 5 minutes. So I might call Rochester's latitude 43 degrees and 10 minutes north, just because it's above 43, but it's not quite half, it's not quite quarter, it's in between. So I might use 10 minutes, approximately. Okay, I think that's it. Yep, longitude's next, so I'm going to stop there. This will be video 1. I'm then going to make another video that now breaks down longitude. Okay, talk to you soon. Bye.